using radian measure. So angles can also be measured in radians. To define a radian, consider a circle with radius r centered at the origin as shown. Okay, so here's the origin, here's our radius, and we're saying this is 1 radian. 1 radian is a measure of an angle in standard position whose terminal side intercepts an arc of length r. So here's the arc length. Because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle, right? We're saying radius is 1. So it's 2 pi in a full circle. And remember degrees, how many degrees is in a full circle? Well, if we remember, that is 360 degrees. To see how that's related. So so degree measure and radian measure are related by the equations of 360 equals 2 pi radians, but we can simplify that, right? We simplify that by dividing by 2 to each side. And so when we do that, we get 180 pi equals pi radians. Okay, if you divide by 2, this is what you get. Okay, so 180 degrees equals pi radians. So now we're going to look at converting between degrees and radians. So if we start with degrees and we want to go to radians, we're going to multiply degree measure by this. So you're going to multiply by pi radians over 180 degrees. 180 degrees. Then to convert from radians to degrees, you're going to use 180 degrees over pi radians, right? Just the reciprocal. One way that I think about this is that if you're trying to convert, so let me write a little bit at the top over here. If you have, say for instance, 90 degrees and you want to convert that to radians, so remembering how to convert, or dimensional analysis if you remember that, you want to get rid of the degrees, so you want the degrees at the bottom, right? So that's the way that I remember it, and then the pi is at the top. It is assumed that if there's no radians that it's pi, right? So the radians is often omitted, so we just use pi. So if we simplify this, 90 goes into 180 2 times, so therefore that would be pi over 2. Right? And then on the other side, if you have radians, say for instance you have pi radians and you want to convert it to degrees, then you would do the pi at the bottom because you want to get rid of the pi over 180, right? So that helps you get rid of the pi and you're left with 180 degrees. So that's how I think about that instead of memorizing the formulas, okay? You think about, if I start with degrees, I need to cancel it. So therefore, the degrees needs to be in the denominator. So let's try. Convert the degree measure to radians or the radian measure to degrees. Now, if there is no degree symbol, then it is in radians, okay? So really important now that you know this, you have to put the degree symbol if it is in degrees. So we want to get rid of the 120, we want to get rid of degrees. So we have 120 degrees, and we're going to multiply that by, we need the 180 degrees at the bottom, and then pi is at the top. So we have to simplify this. So let's see, 60 goes into 12 2 times, and 60 goes into 180 3 times. So it is 2 pi over 3. Now we're going to convert from radians to degrees, so negative pi over 12 times. And we want pi at the bottom and then 180 degrees on top. So our pi cancels. And then 12, we have, we can multiply across 180 degrees over 12. And if you simplify that, 12 goes into 180 15 times, and this is negative. So negative 15 degrees. Okay, so go ahead and try these 4, please. Pause the video and try it out. Again, if there is no degree symbol, then therefore it is in radians. So hopefully you tried this out. So for number 9, you would have 3 pi over 4, so always reduce. Number 10, you would get negative 2 pi over 9. Number 11, you get 225 degrees. Number 12, there is no degrees, so therefore you are using this to convert. Negative 6.28 times 180 over pi. And then, so if you multiply the numerators together, you get negative 1130.4 over pi, and then evaluate it all the way, you would have approximately negative 359.8 degrees, so almost a full circle. So degree and measures of special angles. So this diagram shows equivalent degree and radian measures for special angles from 0 to 360 degrees, or from 0 radians to 2 pi radians. You may find it helpful to memorize the equivalent degrees and radian measures of special angles in the first quadrant, and for 90 degrees equals pi over 2. So what it's saying is that we're going to find it helpful to memorize these radian and degree measurements here. And then all other special angles shown are multiples of these angles, okay? So, just something to think about. And then really on this, what we want to do is be able to convert. So whenever we have radian, we'll convert to degrees. And then if it starts in radians, we'll convert it back to radians, okay? So that's kind of the nice way to do it, so you're not memorizing so many things. There's going to be plenty of things for you to memorize this chapter, and so just remember how to convert between radians and degrees, and that'll make it very nice for you. So let's do sectors. A sector is a region of a circle that is bound by 2 radii and an arc of a circle. Okay, so you have your radii here, and then the arc of the circle. The central angle is theta of a sector, is the angle formed by the 2 radii. So this is the central angle theta. There are simple formulas for the arc length and area of a sector when the central angle is measured in radians. Okay, so we're going to be taking a look at radians. So the arc length S and area of a sector with radius r and central angle theta measured in radians are as follows. So you have to know these formulas. S equals r times theta. Okay, so that's the length of the arc here. Then the area of a sector, that is area, equals 1/2 r squared times theta. So let's go ahead and use that. A softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. So step 1, we're going to convert the measure of the central angle to radians. So notice that 90 degrees is here. So let's convert it. So what we did earlier, 90 times, we want to get rid of degrees, so 180 degrees goes at the bottom and pi goes on the top. 90 goes into 182 times, so it is pi over 2. Okay, so that is our theta. Then we're going to find the arc length and the area of the sector. So arc length, we remember the formula, is S equals r times theta. S equals r times theta. And so in this case, what is r? Well, r is 200 feet, right? That's our r. So the sector equals 200 times pi over 2. So this sector is 100 pi, and then for word problems, we're going to go ahead and multiply the pi through. So this is approximately 314 feet. Okay, so that is the arc length, this length here. So the length of the outfield fence, so you can write a sentence, the length of the outfield fence is approximately 314 feet. Okay, so now let's find the area of the sector. Okay, area of the sector. So that formula, again, was A equals 1/2 r squared times theta. So we have 1/2, the radius is 200 times pi over 2. That's 200 squared. So now this changes to 1/2 times 4,000 over pi over 2, and 2 times 2 is 4, right? So this really changes to 1,000 pi. Then we're going to go ahead and convert it, so it's 31,416 feet. Okay, you multiply pi to 1,000, just use the pi button on your calculator to solve it. Then, of course, write a sentence, the area of the field is what? Okay, and then you write a sentence. Now, try number 13. In example 4, the outfield fence is 220 feet from home plate. So what changes? Estimate the length of the outfield fence and the area of the field. So go ahead and try this problem out. Pause the video, and I'll have the answer when you return. So if you tried it out, the length of the outfield fence is 110 pi, or 346 feet. The fence is 346 feet. Then the area of the sector is 12,100 pi, or it changes to approximately 38,013 feet squared. Okay, so this should be feet squared here as well. So go ahead and try to see if you can do this next problem, number 17, on your own. And I will go ahead and post it in the next video, so if you're interested in this type of problem, just to let you know, this problem, I like this type of problem, so you know what that means. And just try it out, and then if you want to see how I got it, then you can see it in the next video. Thanks for watching.